Okay, I would say that this very first introduction piece is probably the most important for your learning today. We're going to learn, yesterday we dealt with the basics of logarithmic functions. Today what we're going to do is we're going to actually learn how to determine their equations and graph them. And it's not that difficult, but please try to understand this. Y equals 2 to the x. You learned to graph that the other day when I was gone, last Friday to be exact. Do you remember what point on the graph did y equals 2 to the x pass through? 0, 1. Why? Because anything to the 0 power is 1. And you also saw that this function, it trailed off like this, meaning that it had a horizontal asymptote of y equals 0. Well, here's the interesting piece, and I think that the key to you understanding logarithms better is to understand their connection to exponentials. If I write y equals log base 2 of x, these are what we refer to as inverses of each other. Now, you've already learned about inverses. Inverses mean we switch what values? X and y. So if we switch the x and y value here, instead of 0, 1, it will be, so this graph goes through 1, 0. If we switch the x and y values, instead of having a horizontal asymptote of y equals 0, it will have a vertical asymptote of x equals 0. And the graph looks like this. It is the inverse. It is reflected over the line y equals x. Okay, that's the relationship between 2 to the x and log base 2 of x. Okay, and we also learned this the other day. If you have log base 2 of 2 to the x, those cancel out and give you x. If you have 2 to the log base 2 of x, those cancel out and give you just x. So I know that logarithms are tricky, but the key to understanding them, in my experience, is to think of this. Got that in your brain? Okay, then let's move forward and do some concrete examples. It says, find a function in the form of y equals log base a, like I did log base 2, of x. So we want to know what that base is, knowing that it passes through these points. What do you notice all of the functions pass through? They pass through 1, 0, as we just stated, and we understood why. So I'm going to try to determine its base by looking at the second point. Y is 2 is equal to log base a of 25. So we want to understand what a is based off of that expression. That means a base of a raised to the second power is equal to 25. So what would a be? 5. So my equation is y equals log base 5 of x. We determined the a value. So the next one, -1, is equal to log base a of 1 over 6. Or what number do you take to the -1 power to get 1/6? 6 to the -1 is 1/6. So therefore a is 6. So y equals log base 6 of x. 4 is equal to log base a of 10,000. Or a to the 4th power is equal to 10,000. What number do you take to the 4th to get 10,000? A is equal to 10. So you can write y is equal to log base 10 of x, or simply your book would write log of x, because the 10 is assumed. So you need not write it. One is equal to log base a of 7, or a to the 1st power is equal to 7. 7. Okay, so now let's actually sketch these graphs using what we know about the parent function. But before we write these down here, please flip to the very last page so we can put together these notes right here. So we already put together some graphs of exponentials. Now let's put together some graphs of logarithmic functions. As you saw before, the parent function of log base a of x has a vertical asymptote of x is equal to 0. It also passes through the point 1, 0. And it heads off like that. Therefore, the vertical asymptote is x equals 0. What is the domain? Look at the graph. X greater than 0. The range? All real numbers, yep. Natural log is the same thing. It's just log base e. So don't treat it any differently. Depending on the base, the graph might be stretched a little bit more, and that would be it. So you won't show that when you graph it. You simply would just continue to make basically the same sketch. Okay, so don't make it too complicated. Whether the base is e or 5 or 10, we're not going to really change the way that we graph it. You would simply show maybe a different point that it passes through. So don't worry too much about that. And again, the vertical asymptote, the domain, and the range would be the same. So true or false, you may not take the logarithm of a negative number. When I say you may not take the logarithm of a negative number, that means the domain. Are you allowed to plug in negative numbers for the domain? No. Are you allowed to take the logarithm of 0? No. Okay? But you can get out positives and negatives. That's different than exponentials. Y equals 2 to the x. Could you plug in a negative 1 there? Yes. But can you get out negative results? No. Again, the domain and the range flip between the two. Okay? Let's try an example. We don't know how to do that. Okay, log of x plus 2. So we just want to identify the shift. What happens with the shift? Is the plus 2 on the outside or inside? It's on the outside. So it already has a vertical asymptote of x is equal to 0. If I do plus 2, does that change the vertical asymptote? No. But the coordinate that it usually goes through, 1, 0, does that change? What does it go through now? 1, 2. We add 2 to the y value because it's a vertical shift of 2, correct? So it's going to go through this spot, 1, 2. So it says identify the domain, the range, the asymptotes, and 1 point on the graph. So we said the point was 1, 2. The vertical asymptote was x is equal to 0. What's the domain? X greater than 0 in the range, all reals. What's different about letter B? There's two things. Okay, it's minus 2 on the inside, so that's a horizontal shift. It'll be to the right 2 units. What else is different? The base. Don't worry about the base. This was base 10, this was base 3. Okay, don't worry about that for right now. Okay, so it's going to be a horizontal shift of 2. Will that change the location of the vertical asymptote? Yes, it will. Oh, don't like that. So I have a vertical asymptote of x is equal to 2. It used to go through the point 1, 0. Now it will go through. I'm shifting it how many units? 2. So if you shift 1, 0 2 units, it will get to 3, 0. That's all that happens. I continue to start down. I end up just like so. The domain, what's different about the domain this time? In the range. If you look back at the original equation, does that make sense that x has to be greater than 2? Because you cannot take the logarithm of a, and you cannot take the logarithm of 0. So that's why the domain works out like that. See how you can confirm it graphically? So piece those things together as you consider these. All right, what's different about C? Okay, we got a natural log, which really won't change things. It's just a different base, but we have the negative on the outside. What does the negative on the outside do? Vertical flip. How about the +1 and the -3? Yeah, so I'll do the horizontal shift first. It moves my vertical asymptote back 1 unit. So I have a vertical asymptote of x is equal to -1. Now, I had a coordinate of 1, 0. If I move the coordinate 1, 0, 1 back and 3 down, what will be its new location? Very good. 0, -3. And because there's a negative in front, will it start down and finish up, or will it start up and finish down? Start up and finish down. And please be careful in this situation that your graph follows the vertical asymptote and not simply just the y-axis, right? I mean, you want to follow your asymptote. Okay, so what's the domain? -1, range, all real numbers, and my point we stated was 0, -3. Okay, we'll do one more together. You're going to do the last two on your own and put them on the board. What's the only transformation for letter D? Right 4. So x equals 4 is my vertical asymptote. What's the point? Its location used to be 1, 0. 5, 0. Start down, finish up, start up, finish down. Start down, finish up, pass through 5, 0. Domain. And range. Yep. Okay, you do E and F just like we did the previous ones. And when you're done and you're confident, put it up on the board. Doesn't matter if it's right or wrong. We will not make fun of you. And that will be the end of our lesson after we confirm that those two are correct. Okay.